welcome back to KXAN Live. I'm your anchor, Esmeralda Zamora, and this Tuesday we have our Space segment with Eric Henriksen. Eric, how are you doing today?
I'm doing fantastic. The weather has finally turned in the direction I like. I'm the only one.
It's beautiful.
It's beautiful. I think it's beautiful. This is for me. Like this is the rest. Everyone else can be happy about last week's weather. We're finally in a cool zone. I'm cool with that. I get to wear a jacket again. This is kind of my fall jacket. I get to kind of dress like a little chilly. I don't know. I love it. I'm excited.
A little chilly. I like it too. It's very relaxing to just be at home.
Light some candles.
Cover yourself with your blanket.
Bake some cookies. The vibes. I love the vibes.
The vibes. Well, today's vibe is about space, obviously. There's a new discovery. Talk to us about this new discovery.
Yeah, so NASA's released some new research that has found a new fast-moving system. Is a star and a planet that they've spotted. There is like an artist rendering of both the planet and its star, as a small star, and then the speed at which it's moving. You look at those little dots on the screen; those show you, kind of roughly what other things are moving. That long stretch shows you how fast this one's moving compared to the others. So it's a very fast-moving system. They discovered this over several years, first in 2011, and now we have a second confirmation of its existence and its speed. And more research, of course, is necessary, but this could show a new outlook on how our solar system and our universe moves through. Everything moves through it. Our solar system moves through our universe, and things move in our universe.
And this is a fast-moving star and planet, or
right.
What was the wording that they called it?
They called it, it's this fastest-moving exoplanet system. So an exoplanet system is any system that has a world that's outside of our solar system. Mm-hmm. So anytime we discover a planet that's outside of our solar system, it's an exoplanet. And an exoplanet system means like a star with a planet around it. And they discovered this through a thing called microlensing, which basically is observations using gravity and light and mass. So, quick physics lesson, and I'm not a physicist, but this has been explained to me by a lot of physicists, and this is kind of how it works. So if you have something like a black hole, so black holes actually have a great deal of mass, so they're really, really heavy and dense. Think, like a piece of lead. It may not be that big, but it's really dense. So these things like black holes have a lot of mass to them. When gravity is warped around it, but so is light and space. So you actually get these weird warping effects in space around like stars. And this creates this thing called microlensing where you can actually observe further in the universe. With James Webb, we talked a lot about this when the James Webb Space Telescope launched. You can observe further in the universe because light warps around things because of gravity and mass moving things. So gravity, the amount of gravity a thing of high mass exhibits will change how light moves around it. So we were able to observe this through this microlensing effect. So it's farther out there, but we can actually track its movements, which is pretty crazy that we were able to do this.
And this one in particular is going straight through the Milky Way, right?
Right. I think it's closer to the core of the Milky Way. So we're kind of on one of the arms, like further out on the arm, and they're observing this kind of closer to the core, which is kind of a good way to do it because we can actually see, we know a great deal about the stars in that area, and it's easier to track things because we do observe that direction quite a bit.
And you mentioned earlier when we were talking about this that this is not confirmed and it takes quite a bit of time to actually confirm this, right?
Yeah, when you're observing stuff in space, you usually observe it multiple times over long stretches of time. They're going to do another thing in a year to observe it, and this is going to be using the Nancy Grace Roman Space Telescope, and it's going to help us analyze these exoplanetary systems, and they're going to observe this system again to see, is it really moving as fast as it is? We keep talking about how fast it's moving.
Yeah.
It's moving at 1.2 million miles per hour. For people who like kilometers, that's 540 kilometers a second. So pretty fast.
Way faster than us, right?
Right. Our solar system moves about half that, about half a million miles per hour, 500,000 miles per hour is how fast our solar system is moving through the universe. So this is moving about double that.
And what is this planet, which planet of ours is this planet most like?
It's similar to Neptune, which is our 8th planet. I have to count our 8th planet out there. It's a big gas giant. That one is a little bit more watery. It's got a water. I think it's like a high hydrogen level, so that's why it's blue. But it's a gas giant, and so this one's the size. I have the math here. Let me double check. It is about 29 times the Earth's size, the Earth's mass, and it's like kind of a Neptune-ish, like a little bigger than Neptune. So super Neptune.
Neptune is pretty dense then, just like this one?
Neptune is pretty dense, but it's big. So this one's much larger, yeah.
Wow. And You had mentioned to me that this is not the first of its kind, right? There's been others.
Yeah, we've discovered lots of systems like this. This one's the fastest moving system, which is pretty cool. But we discover systems out there all the time, and we use it through that microlensing is one way we discover things that are farther out there. We discover, planets out there. The other ways we can discover it is as like planets move in front of stars or behind stars, they'll disappear or they'll blot out the other ones. So we'll discover little planets that way, and, like a star and like a little dot, kind of an eclipse. Another way we can discover it. So we've discovered systems like this before. This one, and you saw that one picture with all those little red dots, that one there. The little purple ones are moving. Those are other stars and other star systems. And this one's that long red one. This is an artist's interpretation. Keep that in mind. But an artist's interpretation of that, where that shows you the distance it's moving compared to the rest. Those are kind of short. This one's pretty long.
Wow. So when they were discovering this particular star planet, what did they use to discover it? And
they use two different things. The Keck Observatory, I don't remember these because there's so many satellites and stuff. The Keck Observatory and the Gaia satellite. So they use data from those two to confirm the movement of this system, this star system, this exoplanetary, fast-moving exoplanetary system.
And you said moving forward, there's more steps that they have to do to continue to confirm it. What are those steps?
It's basically like more observations. So whenever you're trying to do anything scientific, it's about hypothesis and observation, and then confirming the hypothesis through observation. So you have to, keep checking this. Is it really moving this fast? One thing I thought was interesting they talked about was this is moving left to right, is what we're observing, in our sky. But it could be moving this axis too. So it could actually be moving faster or slower, depending on how much it's moving, back and forth.
So it's moving, but at the same time, it's moving back and forth.
It could be moving, so you could be going. It's likely not heading in a straight line, which is how we're observing it. It's probably could be heading like this. I'm trying to do it with the camera. This. Which way is the camera? There. Okay, so it's like curving. It could be going straight across and then kind of
curved.
Right, and then it could be doing in different directions. So from our perspective, it's just doing this, but it could be doing this, or it could be doing this. So it could be doing all sorts of motion. But the only way to confirm that is through long-term observation of the object. How is it moving? What is it moving past? So we'll just do that for a long time.
For probably a year, right?
They'll check in on it in a year, and we'll keep checking in on it periodically. There's so many stars, so many systems. They're always just checking in on them. You don't sit there and just watch one. First of all, things change over time. Yeah. So you take a note, and then you catalog the change, and you come back later and catalog the change, that kind of thing.
Well, if there's so many of these things occurring, I wonder how they assign each one to the different scientists.
I think it's you take a curiosity. I've talked to a lot of scientists about this. They see something they're interested in, and they're like, I'm gonna track that particular thing. So you leave it to the individual to kind of figure out, what do I want to track? What do I want to learn more about? And then some things are, of course, assigned. It's to get a list, and you got to work your way down the list. Eventually, everything comes down to a list, right? Yeah. So that's what happens.
Do they name things like this?
You will typically, we've talked about this in the past, where they name objects, remember, and there's so many objects we discovered. The naming process takes a little bit of time, and the person who discovered it gets first rights to naming, and then it passes along. There's a nomination process. So for a while there, it's just going to be letters. I don't even have the letters in front of me because it's just some weird letters. Yeah. It always is just some weird letters. That it usually is like who found it, what date it's found, piece of the sky it was found in, maybe even what equipment or what day it was discovered in. All the systems are a little different, but they're obtuse to us mortals.
Yep. Well, my next question is, you mentioned that it's in the center of the Milky Way. Does it have any form of destruction for us?
No.
No? Good.
No. These things are so far away. These are millions of light years, billions of light years away. That means it would take billions of years traveling at the speed of light for it to reach us. No, there's no threat at all. There's much closer threats we got to worry about. Not this one.
Well, those are all my questions I had on this. Is there something that we didn't get to touch on about this discovery?
No, it's great. It's really cool. It's we get these occasionally. The other thing I forgot to mention was it may not be a star system. The other option is it's a rogue planet that's about 4 times the size of Jupiter. So we have rogue planets. Rogue planets are planets without star systems, and they're zipping through our cosmos all the time. One theory I read about how our moon was created was that we were collided with a rogue planet. So they do exist. They're out there. They do spot them from time to time. No star system harder to spot. Light doesn't reflect off them because there's not a nearby star. But sometimes you just have a planet that's zipping through the darkness of space without a light source.
Wow, I wonder who's on them.
That's a great question.
I wonder if they can
And
see
a terrifying thought.
Well, what else is happening in space right now?
Oh, just constant observations. We got, what's today? Today is the 11th, which means we're reaching the moon with Firefly Aerospace on March 2nd. So we're just 2.5, almost 3 weeks away. And yeah, that's the big thing for me coming up. That's what I'm looking forward to. Also, look for a story later this week on lasers. I'm looking at a new system that's using lasers to protect microchips from radiation in deep space. A lot of radiation in deep space, you got to protect it. How are we testing that? Lasers.
Lasers. The last space-based segment we did, we talked about an asteroid possibly hitting Earth, maybe not.
Yeah.
How did that go?
We weren't hit. But there is another one I read about in the news
I saw
yesterday.
headlines that were a little saying that it was coming towards us. But
That one's not a destroyer. That one's not a human race wiper-outer. It could cause some damage, but I think the ratio, not the ratio, the probability increased of it colliding with the Earth. Not a 1-to-1, it was just slightly increased. But remember, we're working on ways to deflect asteroids, like the DART program, which will launch a rocket into an asteroid and redirect it. So we're working on things. I think this one's like early 2030s. I think I want to say 31 is what's on the top of my head. But that's the next one they're really worried about, and hopefully by then we have DART fully operational. I mean, they already used it once, so we always got to make sure we can use it and do the math. Do the math right. You want to make sure if you're going to hit an asteroid and move its course, you want to make sure you hit it the right direction. So they're working on that. I'm thinking no real worry, but even then it's fairly small. It would cause some damage. I read it was similar to the Tunguska event, which is when a large meteor struck northeastern Russia and wiped out a forest.
Forest?
Yeah, it hit and there's a big boom.
That seems
Look
like
it up.
destruction
There's a
to
lot
me.
of science. I mean, there's destruction. A lot of science fiction written around that event. But yeah, I think the comparative impact would be about the same as that. So
Well,
something to
area
watch
is
out
it
for.
hitting?
Well, that's always the question. No telling. The likelihood is ocean. We have a lot more ocean. That's 70% of the planet is ocean. So most likely, if we do get hit by something, it'll hit the water, and hopefully that's where it hits.
Hopefully it doesn't cause anything else after it hits the water.
Hopefully, depends on where it hits, I guess. We'll find out. I'm not a physicist when it comes to tsunamis. I can't tell you that. I'm not a physicist at all. I'm just a nerd who's interested in space stuff.
Well, thank you so much, Eric, for sharing all of this with us. And I'm sure we will have an article on this that people can go on to our website, kxcn.com. On the homepage, you can find it there and read a little bit more about this new discovery.
Perfect. Thank you so much.
Thanks for being here. And that's all we have today on the Space Base. We'll be back next week with another segment and another topic for everyone to join us there. Thank you.